Always know that whenever you've done this, plot your real number line system so that you will find the interval of your domain. Now let's do that. We have the real number line system, negative infinity, 0, and positive infinity. This negative infinity means that there are infinitely many negative numbers, same as infinity. Infinity is not a number, it's a concept. It has no end. Good. So now let's identify these 2 points on our number line. We have negative 3 here, and we have positive 3 here. Always make sure you identify those points in your real number line system. Good. Now, how do we find the domain from here? Something you have to understand. X is not equal to minus 3. X is not equal to plus 3. X is not equal to minus 3. Draw an open circle on 3. That is, we are avoiding it. This open circle means that we are avoiding it. That's minus 3. Then X is not also equal to plus 3. Draw also an open circle and avoid it. All right. Now, minus 3 and plus 3 should be taken off our interval of domain. So what's the answer? It means that every other point from negative infinity to 3, this is the first interval. Let's write it down. Therefore, the domain of this function, the first interval, negative infinity to 3, negative infinity, comma, 3, comma, minus 3. Close the bracket. All right. Now, what's the next interval? You see this negative 3 down to 3. This is the second interval here. This is the first. This is the second. Then, lastly, from this positive 3 down to positive infinity. This is the third interval. You can see that there's an open circle on minus 3, it's not included. There's an open circle on 3, not included. All right. That's why I started by saying the interval is from negative infinity to negative 3. Remember, I'm using that open interval notation. That is, we are excluding negative 3 from our interval. Union the second interval. What's the second interval? What's the length of the second interval? Negative 3 to 3. What kind of interval do we use? Open interval notation. Look at this. Negative 3 down to what point? 3. That's the second interval. Then the length of the third interval, union union 3 to positive infinity. So this is the domain of the given function. Negative 3, comma 3, union negative 3, negative infinity, comma 3, union negative 3, comma 3, union 3, comma infinity. This is how you write the domain in interval notation form. Better still, you can leave your answer in this form, all right? If you are required to leave your answer in this form, good. But mostly, you'll be required to find it in the interval notation form. It means that every other point on this number line, these intervals, if you pick any other negative number, pick negative 5, put it here. Your function will be defined. Let's try it and see. If you pick negative 5, put it here. Negative 5 squared will give you 25. 25 minus 9, 16. So the denominator is 16. It is defined. Pick from within here. Between negative 3 and 3, how many numbers? They are both negative numbers and positive numbers. Let's pick negative 1. All right? Because it falls in this interval. Negative 1 squared is 1. 1 minus 9 will give you minus 8. It is defined. The denominator there is defined. Then pick from here, 3 to infinity. Pick 4. 4 is a positive number. 4 squared will give you 16. 16 minus 9 will give you 7. It is defined. You get it now. So every other point will give you a defined function, but on minus 3 and 3, it will give you undefined. Pick negative 3, put it here. Negative 3 squared is 9. 9 minus 9 is 0. And remember, we are trying to avoid over 0, undefined. Pick positive 3, put it here. 3 squared, 9, 9 minus 9, 0. It means that the only 2 points that will give us an undefined function here is negative 3 and 3. So we exclude it from our interval, and this is our domain. Thank you. Hello, everyone. Again, we have an example here, still on domain of function. All right, still on domain of function. And like I always tell students, if you want to be good, very good in mathematics, ensure that on each topic, you solve at least 25 questions in each topic. So you master the concept, the background, and the concept of that particular topic, what the topic is all about. You can't just solve an example or 2 or 3 and say you are good there. No. Solve at least 25 exercises on each topic for you to be sure, for you to know that you've mastered that topic. That's what I tell students. So that's why I'm still taking my time to solve questions on domain of functions. All right, we have a question here. Different from others, right? I know, but very simple. Same principle, very simple. What we have here is a rational function. 6x squared plus x minus 7 over x squared plus 6x plus 8. Now you look at this. Like I said, it's a rational function. How do you find the domain here? For rational function, our emphasis is on the denominator. We have no business with the numerator. Emphasis denominator, because it is the denominator that will determine if that function is defined or not. Even if we have something, whatever we have in the numerator, we don't mind. The denominator that will always determine what that function will be. All right? And remember, we are trying to avoid over 0 in any rational function. Good. Now, the first thing to do, you've noticed that it's a rational function. Set the denominator not equal to 0. So we have this guy, x squared plus 6x plus 8 not equal to 0. That's the first thing. Like I said, why are we always doing this? We are trying to look for the point of x that will make that function undefined. Then we avoid that point or those points. That's why we are doing all of this. So here, what you have is a quadratic equation. Find x. Simple as that. All right? By factorization. Remember factorization in quadratic equation, right? How to factorize. This is the sum of term. This is the product of term. What are those two numbers that when you add, it gives you 6x? And when you multiply, it gives you 8. Those two numbers are 4 and 2. Positive 4 and 2. When you add them, it gives you 6. When you multiply them, it gives you 8. So factorizing this quadratic expression gives us x plus 4 times x plus 2 not equal to 0. This quadratic factorization, you still have the idea of that. So I don't need to do all of the whole steps here. All right. If you open this bracket, it's still going to take you back to what you have here. Good. So this guy must not be equal to 0. This other guy must not be equal to 0. So we have x plus 4 must not be equal to 0. And x plus 2 must not be equal to 0. Now, what are the 2 points of x that makes our function undefined? Bring this guy here. X must not be equal to minus 4. Okay? And x must not be equal to minus 2. Can you see this now? Bringing positive 4 to this side gives us negative 4. Bringing positive 2 to this side gives us negative 2. So these are the 2 points that must be excluded from our interval of domain. That's why it's always necessary you find this, then plot your answers on your number line system. Always make use of that. So the next thing, get your number line system, negative infinity, 0, and then positive infinity. What are those 2 points? They are all negative numbers, so it means that they will lie in the negative region. So let's extend this further. This is 0, and this is positive infinity. So we have -4 and -2. Now you see this. These are the 2 points that we must avoid. How do we avoid them? Draw an open circle on it. Draw an open circle on it. So now you can see that we still have 3 intervals as our answer. Every other point from negative infinity running to 4. That's the first interval. From here to here. First interval. And every other point running from here. Second interval. And every other point that runs from -2 down to positive infinity. That's the third interval. So how do we write our answer in the interval notation form? Therefore, the domain of f is giving us negative infinity to -4, union -4 to -2. Finally, union -2 to positive infinity. So this is the domain of the given function. In interval notation form, this is the domain. Like I said, you can still leave your answer in this form. That's if this is not equal to, sorry, corrected it now, it's not equal to 2. Like I said, if your examiner or your course lecturer requires you to leave your answer in this form, you leave it. But this is how it is written in interval notation form. If you pick any, like I explained in the previous video, pick any other number from negative region, put it here, it's going to be defined. But on -4, it's going to give you undefined. Try that. -4 squared, 16, plus -4 squared plus end that video. End it. End it. Let's just leave that. All right. Find the domain of the given function. F of x equal to all squared roots x plus 9. Notice something here. The expression is hiding under a radical sign. And the radical sign is a square root sign. All right. Radical functions are functions that hide under a root sign. Those are radical functions. Now you see, this is a radical function. Unlike the previous examples we've solved in my other video on polynomial and rational function, this is a radical function. How do you identify, or how do you know it's a radical function? If it is carrying a root sign, all right? That's a radical sign. What you have inside is called a radicand. This is the radicand. And this is the radical sign, or the radical.